Okay, for your bell ringer today, I just stole these 4 problems right off your fair game review for Chapter 2. It says evaluate the expression. So 1/8 plus 1/9. Remember, we need comma denominators. So it's going to be a fraction plus fraction equals some fraction. And 8 and 9, a comma denominator would be 72. So I'll put that down for my comma denominator, which is common all the way even through the answer. 8 times 9 is how we got 72, so 9 times 1 is 9 on the top. 9 times 8 is 72. 1 times 8 is 8. And now, 9 70-seconds plus 8 70-seconds is 17 70-seconds, and that cannot be simplified. Here, subtraction, much the same, except 12 is actually my comma denominator I'm going to use here, so I'll write this out. Put 12 for my comma denominator. This fraction gets to stay the same because it already had 12. 4 times 3 is how I got 12. 1 times 3 is 3. 7 twelfths minus 3 twelfths is 4 twelfths, which can actually still be simplified, dividing top and bottom by 4 to get 1/3. Multiplying fractions, love it. Multiply. First I look to see if I can simplify. And remember, when we're multiplying fractions, we can actually also simplify like this, but this can't be simplified, that can't be simplified. So 5 times 1 is 5. 9 times 3 is 27. The end. Love multiplying fractions. Dividing fractions almost as easy because remember, we keep the same first fraction and we multiply by the reciprocal of the second fraction, which is when I just turn that thing over, and instead of 11 over 16, it's now 16 over 11. Well, now I can simplify. I can't simplify this. I can't simplify this. I can't simplify here, but right here I can. 8 goes into 8 one time, and 8 goes into 16 twice. 7 times 2 is 14 across the top, and 1 times 11 is 11 on the bottom. Improper fraction is okay to leave it like that. So that's simplified to me. If you wanted to go mixed number, you could do 1 3/11, but I would just leave it as a simplified mixed number. Improper fraction. Improper fraction is just fine. All right, well, this is lesson 2.1, and it starts on page 46 in your textbook. We're starting out with the key idea, rational numbers. So a rational number is a number that can be written as a over b, where a and b are integers and b cannot be 0. Well, we knew b couldn't be 0 because you can never have 0 in the denominator, because that would mean you're dividing by 0. But really, a rational number is any number that can be written as a fraction, or any number that can be written as a ratio, which is where rational comes from. A ratioable number. So we can turn it into a ratio. I love this thing right here. This little, it's kind of like a Venn diagram, although there's no kind of like overlapping circles where they don't overlap. But whole numbers, we talked about whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, and it goes on, but there would just be the 0 and the natural number. So all the numbers that you first learned. Then integers does not just include the negatives, which some people will look at this and say, oh, the integers are just the negative numbers. No, this whole oval here is also in integers. So 0 is an integer, 4 is an integer, -2, -10. Notice, no decimals, no fractions, though, for integers, okay? And then we have rational numbers. And with rational numbers, we get to include negative fractions, positive fractions, negative decimals, positive decimals, repeating decimals. So lots of stuff that can go into rational numbers. And rational numbers is what we're going to talk about for Chapter 2. Kind of like Chapter 1 where we added and subtracted integers. Well, now we're going to add and subtract rational numbers, just meaning we can now start talking about decimals and fractions in addition to talking about positives and negatives. All right, so here we go. Repeating decimal. Because you can divide any integer by a non-zero integer, you can use long division to write fractions and mixed numbers as decimals. So how do you write fractions as decimals? By dividing you can use division, top divided by bottom. These decimals are also rational numbers and will either terminate or repeat. So a terminating decimal is a decimal that ends. 1.5 is a terminating decimal because it stops right after the 5. Negative 25 hundredths or negative 0.25 terminates because it stops. 10 and 625 thousandths stops. So these are all examples of terminating decimals. Repeating decimals is a decimal that has a pattern that repeats. For instance, negative 1.3 repeating, negative 1.33333 forever. We show negative 1.3 with that little bar over the 3, which means the 3 keeps repeating. Notice the bar doesn't go over the 1 as well. In fact, the bar should never go over that decimal, okay? It's always behind the decimal. And then we have another one here, 0.151515, where the 15 keeps repeating. So 0.15 repeating, the bar goes over the 1 and the 5 to show that they are both repeating. Okay, rational numbers. Writing rational numbers as decimals. So here, negative 2 1/4 as a decimal. Well, first we turn it into a complete fraction. That's one way to do it. And then you divide here, top divided by bottom. However, notice the 2 in the decimal, that shows that that's a whole number, and the 2 out front in this mixed number, that shows that's a whole number. Those are always going to be the same, okay, because they both are telling you how many whole number parts you have. So those will always be the same. So really, if you wanted to, you would only have to do the division for the fractional part. 1 divided by 4 would have gotten you the 0.25. Your choice, you can turn the whole thing into a fraction and then do the division, or you can just take the whole number part and put it out front and then divide for the fractional part. Your choice. But not done here. The answer isn't 2.25. If it's a negative fraction, it better be a negative decimal because we're showing that they're equal. And yes, they did make sure it was a negative decimal. Write 5/11ths as a decimal. 5 divided by 11. You do that division, you get 0.45 repeating, and it was a positive fraction, so it's a positive decimal. Here are some for you to try. Okay, so for number 1 here, we have negative 6/5. So to turn this into a decimal, we do top divided by bottom. Always top divided by bottom. This is 6 divided by 5. So 6 divided by 5 means the 6 is what goes in the box. Top in the box. Always top in the box. Well, we're going to turn this into a decimal, so I'm going to put a decimal right here right away. And remember, I can annex as many zeros back here as I want to. We'll start with 3. 5 goes into 6 one time, which is 5. Bring down a 0. 5 goes into 10 two times, which is 10. Oh, happy days, we're all done. Excellent. So 1.2. Is that my answer? Of course not. It was negative 6/5, so it better be negative 1 2/10. For the next problem, negative 7 3/8. Now this 7 part is the whole number part, so I know that 7 part is going to be the whole number part for my decimal as well. I'm going to turn this 3/8 into the partial number that goes behind the decimal. So here we go. I'm going to do, remember it's top divided by bottom, 3 divided by 8. So 3 in the box, 8 out here. And I'll put a decimal with a bunch of zeros. Put my decimal up there. So 8 into 3, no, it doesn't go. 8 into 30, that goes 3 times, which is 24. 6, bring down a 0. 8 into 60 goes 7 times, which is 56. Subtract, bring down a 0. 8 goes into 40 5 times, which is 40. Now, remember, I still have this -7 that's out here I didn't take care of. So my answer is -7.375. -7 and 375 thousandths. At the end of these problems, I always do a quick double check. Negative fraction, negative decimal. Okay, cool. Well, now, notice I was trying to get away with putting these numbers on my paper already, and I've already come down to where this problem would have been, which is one reason I try to tell you guys not to number your paper and get the problems on there first. So I got caught by my own problem there. Here we go. So I'll put number 3 up here, because remember, we do this nicely and neatly. We don't cram things together just to get them to fit. Here we go. 3/11, -3/11, that is. So what do? 3 divided by 11. 3 in the box, 11 out here. And I'll put a 0 and I'll put a decimal, annex some zeros here. I know dividing by 11 usually gives us a repeating decimal. So let's check this out. 11 into 3, no. 11 into 30 goes twice, which is 22. 11 into 80 goes 7 times, which is 77. Bring down a 0. Notice all of my numbers have to be lining up or you're going to get messed up here. 11 goes into 32 times, which is 22. Wait a minute. We already did this. So I know that it's going to keep repeating now. 0.27272, blah, blah, blah. So for my answer, I'll put a 0 here. 0.27, where the 2 and the 7 are repeating. And the reason I put that 0 out there, it's not bad to put the 0 out there. In fact, you should probably get in the habit of doing it, but especially when it was a negative. So negative, I don't like the negative decimal because then it sometimes just kind of looks like you left some smudges out there. Negative 0.27 with the 27 repeating. And number 4. So turning a fraction into a decimal is not tough stuff, but it does take a little time, and don't just rush on it. It's 1 5/27 here. 1 5/27. So I'm going to turn the 5/27 part into the decimal. My 1 is just going to stay. So top in the box, 5 in the box. You might think, oh, putting the 27 in would be so much better because it's the big number. I don't care. The top goes in the box. 5 divided by 27. So we'll annex a few zeros here and put that decimal straight up into the quotient. 27 into 5, no. 27 into 50, 1 time, which is 27. Subtract, get 23. 27 into 230 goes 8 times. 56, 16, and 5 is 21. Subtract 14, bring down a 0. 27 goes into 140 5 times. 27 times 5 would be 5, and 10 and 3 is 13. Subtract 5, bring down a 0. And now look, 50, that's where I started. So this is going to start repeating. Okay? Any mistake in here, though, any mistake in here, and all of a sudden this number is going to be a little off, and you're going to get this number going way out here. If you ever are dividing to turn a fraction into a decimal, and your answer just keeps on going and going and going, you have probably made a mistake, okay? So this is repeating. Remember, that's not my answer. You might be like, yay, I just did a long division problem. I'm all done. Good for me. Make sure that you wrap up the problem the right way. It was 1 5/27, so it's going to be 1 and 185 repeating behind the decimal here, okay? And it was positive, so it's positive. So those problems take a little bit of time, but they're not hard stuff. All right, well, for example 2, writing a decimal as a fraction. I like this little study tip out here. If P and Q are integers, so they're just saying these are numbers here, you can have the negative out front. That is equal to have the negative in the numerator, and that is equal to having the negative in the denominator. So it doesn't matter if you have the negative out front, up top, or on the bottom. Those are all equivalent. Okay, so now write negative 0.26 or 26 hundredths as a fraction in simplest form. If you know how to say these correctly, 26 hundredths, then you know how to write them as a fraction, 26 hundredths. It doesn't get much easier than that. So make sure that you're saying these numbers correctly. Negative 0 and 26 hundredths becomes negative 0 and 26 hundredths. All right, so if we can say them correctly, then we're going to be able to convert those very easily. If you don't know how to say them, and then you should simplify. So they're both even, so I know I can divide top and bottom by 2, which if I divide the top by 2, I get 13, and if I divide the bottom by 2, I get 50. The negative comes along, don't drop the negative, common mistake. If you don't know how to say these numbers, then the other way you can do it, it says right here, write the digits after the decimal point in the numerator. So after the decimal, we just have a 26 here, so you write those in the numerator. The last digit in the hundredths is in the hundredths place, so use 100. So that's in the hundredths place. But if you didn't know that was the hundredths place, which you should, but if you didn't, 2 numbers behind the decimal, 2 zeros behind the 1. Okay, 2 numbers behind the decimal, 2 zeros behind the 1. Let's try some of these on our own. Okay, so this first one, negative 0.7 is how most people would say that, but we're supposed to say negative 0 and 7/10, which makes it super easy to write, but they're not much harder to write if you don't know how to say them. This will obviously be negative, so I'm going to put a negative there. I put all of the numbers that are behind the decimal on top of the fraction bar, so 7. And then there's one number behind the decimal, so I put 1 0 behind the 1, negative 7/10. For number 6, and this cannot be simplified. For number 6, positive decimal, so I will have a positive fraction. I put these numbers behind the decimal on the top, 125. And I put a 1 with 1, 2, 3 zeros behind it because there were 3 numbers behind the decimal. Or you just know that that number is read 125 thousandths, and it's 125 thousandths. Now this can be simplified, and let's see, what can go into both of these numbers? Well, I know 5 can go into both of them, because if it ends in a 5 or a 0, you can divide by 5. 5 goes into 125, goes in 25 times. 5 goes into this 200 times. Well, I'm not done. It ends in a 5 and a 0 again. I could divide by 5 again. 5 goes into 25 5 times. 5 goes into 200 40 times. It ends in a 5 and a 0 again. I can divide by 5 again. 5 goes into 5 once. 5 goes into 40 8 times. 1/8. Positive 1/8 because it was a positive decimal. Number 7. When I turn this into a fraction or mixed number, that negative 3, the integer part, is going to stay the integer part. So negative 3, I'm just pulling right out front here, and then I'll have some fraction behind it. I have a 1 behind the decimal and 1 number behind the decimal. So 1 0 after my 1. Negative 3 and 1/10. Negative 3 and 1/10 is how we say that. Quick double check, negative mixed number because it was a negative decimal number. And number 8, isn't turning decimals back into fractions so much easier? Yes, it is. I knew you'd agree with me. My negative 10 is going to be the whole number part here, well, the integer part. And I have this 25 after the decimal, so that's what goes on the top of the fraction bar, and a 1 with 2 zeros behind it, because there are two numbers behind the decimal there. Negative 10 and 25 hundredths. But this fraction part can be simplified. Again, it ends in a 5 and a 0, right? So I could divide by 5, but I also know that 25 goes into 25, and 25 goes into 100, because quarters go into $1, right? So my whole number, my integer part stays the same, negative 10, and I'm dividing top and bottom by 25 to get 1/4. Negative 10 and 1/4. Well, the last part of this section, other than turning fractions into decimals and decimals into fractions, is then ordering rational numbers. And when we're going to order rational numbers, for instance, these right here, if we were going to order these from least to greatest, if you have a number line, handy dandy number line, we'll go ahead and pull it out and put them on there. But you should turn them all into a common representation. So turn them all into decimals or turn them all into fractions. But if you turn them all into fractions, then you're going to have to find common denominators, a common denominator, so that you can order them. Easiest thing to do is turn them all into decimals, because putting decimal numbers in order is a whole lot easier than ordering fractions. So we're going to turn all of these into a common representation. Negative 13 over 10 is negative 1.3. Negative 2 1/5 is negative 2.2. And negative 2/11 is negative 0. With a 1/8 repeating. So now that they're decimals, those are much easier to put in order from least to greatest. And then you just go from the coldest temperature up to the warmest temperature. So negative 2.2, negative 1.3, negative 0.8, and finally negative 0.18. And you might say, wait a minute, this is 8. This is 18 repeating. This has got to be way... No. Remember, we just go one digit at a time. So here we're looking at the integer part, negative 2. Makes that the lowest. Negative 1, that makes that the next lowest. These are both 0 in the ones place, so we go to the tenths place. And here's an 8, and here's a 1. We make our decision right there. Remember, we go one digit at a time. Or if you wanted to make these look similar, you could make that an 80, because we could always annex a 0 behind it. Okay? All right, so we put them in order from least to greatest by putting them all into the same representation. Okay, so for this lesson, 2.1, we'll be working on problems 1 through 35. All of them found on page 48. Okay, for the first couple here, vocabulary. Is the quotient of two integers always a rational number? And you might think yes, and you'd be right almost all of the time, except you could never divide by 0. And 0 is an integer, so there is a quotient of two integers where the answer would actually be undefined, okay? So, which is not rational. Okay, so that would be the one example, the one exception that makes this a no. Writing. Are all terminating and repeating decimals rational numbers? Yes. Okay, if you can write it as a terminating decimal or a repeating decimal, then we can write them as fractions, which are ratios, and that makes them rational. Here, it just says, tell whether the number belongs to each of the following number sets. So, rational numbers, integers, and whole numbers. Well, this first one is not a whole number because it's negative, but it is an integer, and it is a rational number. Number 4, it's also a rational number. It's not an integer because it's got that fractionally decimal part. So it's just a rational number. Here, this is a whole number, an integer, and a rational number. And same for number 6, a whole number, an integer, and a rational number. Okay, so they're all rational numbers. this one, that's all it is. This one here these three are also integers, and these two are also whole numbers. Down here, tell whether the decimal is terminating or repeating. Well, here, it doesn't terminate, keeps going on and on and on, and it keeps going 4, 8, 4, 8, so it's a repeating. This is terminating because it ends. This is terminating because it ends. And this is repeating because it's got the repeating bar. Negative 5.236363636. The 2 is not repeating, just the 36 is repeating, shown by that fraction bar. I mean, not fraction bar, repeating bar. Okay, for these next problems, we're turning the rational number. We're writing these as decimals. Remember, top divided by bottom, top in the box when we're doing long division. So this would be 7 divided by 8. The 7 goes in the box. Now, I'm not going to show you a bunch of long division problems. I'm assuming it's 7th grade. You know how to do long division. Number 11, you should have gotten 0.875 when you're all done here. For number 12, you should have gotten 0.09 with the 0.9 repeating. For number 13, negative 0.7 with the 7 repeating. For number 14, negative 0.425. For 15, 1.83 with the 3 repeating. For 16, negative 2.94 with the 4 repeating. For number 17, you should have gotten negative 5.583 with just the 3 repeating. And finally, number 18, 8.681 with the 8.1 repeating. For the error analysis on this, describe and correct the error in writing the rational number as a decimal. So what did they do wrong? The bar should be over both digits to the right of the decimal point here. It should be negative 0.63 with the 6.3 repeating, not only the 3. Okay, for these problems, write the decimal as a fraction or mixed number in simplest form. So you can go back to the lesson to see how to do this if you need a reminder, but the answer for this one, and if you can read them correctly, then you will get them correct. This is negative 9/10. So negative 9/10. Positive. So number 21 is positive 45 hundredths, which simplifies to 9/20. Negative 258 thousandths, which simplifies to negative 129 over 500, which doesn't simplify more than that. For number 23, negative 312 thousandths, which simplifies to negative 39 over 125. For number 24, negative 2 and 32 hundredths, which simplifies to negative 2 and 8/25. For number 25, negative 1 and 64 hundredths, which simplifies to negative 1 and 16 over 25. For number 26, 6 and 12 thousandths, which simplifies to 6 and 3 over 250. And number 27, negative 12 and 405 thousandths, which simplifies to negative 12 and 81 over 200. Order the numbers from least to greatest. For these, you should write all of these as decimals. Write them all as decimals, and then order the decimals. Once you order the decimals, then go back and put these numbers right here in order from least to greatest. When you do that, for number 28, going from least to greatest would have been negative 7/3, then negative 3/4, 0.5, 2/3, and the largest would have been 1.2. For number 29, putting these in order, remember you turn them all into decimals first, but then these are the numbers you have to put in order. You would have gotten negative 2.5, negative 1.1, negative 4/5, 0.8, and finally 9/5. For number 30, putting them in order from least to greatest, negative 8/5, negative 1.4, negative 0.9, 1/4, and then 0.6. For number 31, you should have gotten negative 9/4, negative 0.75, negative 6/10, 5/3, and then 2.1. For number 32, negative 7/2, negative 2.8, negative 5/4, 1.3, 4/3. So that one was nearly in order, just the way it was written. Number 33, negative 2.4, negative 2.25, negative 11/5, 15/10, and then 1.6. All right, on to the last two. For these last two, it says you lose 1/4, 2 dimes, and 2 nickels. Write that amount as a decimal. Well, you lost it, so it will be negative. I mean, losing money is always negative, right? But 1/4, 2 dimes, and 2 nickels. So that's 2 dimes is 20 cents, 2 nickels is another dime, so that's 30 cents plus a quarter is 55 cents. Negative 0.55. Okay, for part A, negative 0.55, and then it says write that amount as a fraction in simplest form. So for part B, we'll put that negative out front like that, and then that 55 goes on in the numerator, and on the denominator we would put 1 with 2 zeros or 100. Obviously that has to be simplified. We can simplify by 5, turning this into negative 11 over 20. Negative 11 over 20. And then finally, the very last problem, it says a box turtle hibernates in sand at negative 1 5/8 feet. A spotted turtle hibernates at negative 1 16/25 feet. Which turtle is deeper? Now, you could just find a common denominator for these, or, which 200 would work, but you could also turn them both into decimals. Then you're saying which turtle is deeper or further from the ground. So we're looking at whichever one is the larger negative number. And by more negative, I should say, not larger negative, more negative, because that means it's deeper. And when you do that, the spotted turtle at negative 1 16/25 feet would be deeper. Awesome. Well, now you can go and do the homework, which is journal page 28. Have a great night.